Hi, hope you're doing good. Welcome back. Hope the first lecture in chemistry for the bridge course, you liked it. Welcome to the second session in the introductory course or the bridge course in chemistry. My name is Adil Khan. I am chemistry teacher at Base Education Services. So I welcome you again in the second session. Yesterday, in the last session, when I was leaving you, I have given a QOTD, that is question of the day. So let's discuss that first, then we will move inside and discuss the content of today's class. So let's start. I hope it is done. And one more thing, I hope all of you are maintaining a running notes. I expect you to maintain a note. So if you haven't for the first session, you purchase a 200 pages notebook or 100 pages notebook, and in that notebook you write the running notes, the way journalists they write the note while taking some interview. So you maintain the same way because it will help you in the test which will be done towards the end of this bridge course schedule. So let's start the session number 2. So this is QOTD of the last lecture. I believe you know these questions. So let's go and discuss the answer of these. Yeah. So the first one, name 2 toxic metalloids. So there are 7 metalloids which we discussed yesterday. Name 2 of them which are toxic in nature. What will be the answer? Arsenic and antimony. That's the correct answer. Arsenic and antimony, that is SB, strontium. So that those two are the answer. So arsenic and your antimony falls in this category. Uh, even there are few other metalloids which are toxic like boron, polonium. Polonium is radioactive and tellurinium also, but antimony and arsenic is the expected answer here. Antimony, arsenic, the contamination you will see in the soil and the water. Whereas your antimony, the name strontium, it is the Greek word, okay? And it comes from a word of a ore. Ore is nothing but a type of compound from which you extract a metal. So from there, the word strontium come into play. That is nothing but the antimony part. Second one is name the most electronegative element. So the most electronegative element is fluorine. The electronegative value is 4.0 on a Pauling scale. There are 2 scales for electronegativity. One is a Pauling scale and one is the Mulliken scale. But in India, we are dealing with Pauling scale. Now, what is electronegativity? In a layman term, I will explain you. In the coming slides, I will explain you that in detail. For example, you are there along with your friend. So this is you, and this is your best friend. You went out to do some sort of party to some restaurant. You contributed 100 rupees, your friend contributed 100 rupees. But your friend have some other plan. He want to go and see a movie. For that 200 rupees he need. So he convinced you to come out to a restaurant with 100 rupees his contribution and 100 rupees your contribution. But he will start giving some sort of reason, excuse or bahana that see, I am not feeling well, I have a food poisoning, bad stomach is there, my mother is calling, my father is calling, my dog's birthday is there, so I'm going. So you give me this 100 rupees of your contribution, I will return it back tomorrow when we will meet and have a outing again. And he will take that 200 rupees along with him, in which 100 rupees is your contribution. So this your friend is electronegative in nature. So electronegative, basically it's a type of atom in which the atom will take away both the electrons in a bond. So that is known as electronegativity. In detail, I will explain you in the coming class. So answer for the second one is name the most electronegative element. That is nothing but your fluorine. Why it is highly electronegative? Because of the small atomic size and high nuclear charge. Everything will be done with time. Third one is name a lustrous non-metal. Lustrous means shine. Whenever you cut, there is a sign there. Yesterday I explained you that how electrons interact with the light and they will produce the brightness or the shine. So name a lustrous non-metal. You have any idea what is the answer? It is purple in color. The answer is correct. It is iodine. Along with iodine, there are few other elements, non-metal also, which is colored. But the expected answer is this, which is given in the literature and the books. So we are going ahead with that. Fluorine is a type of halogens. Halogen means color producing elements or salt producing element. We will study with time all that things. So iodine is the answer. Next one, name a metal which is a bad conductor of electricity. What do you think? What is the answer? Let me give you a hint. It starts with H and it comes from a Latin origin, that is hydragyrum. So answer is mercury, Hg. It is a bad or a poor conductor of electricity for you. There are many other metals who are bad and poor conductor of electricity, but the expected answer for you is mercury. So mercury is a bad conductor at this point of time. Next is why solids are non-compressible in nature. Now, yesterday when I was discussing solid, liquid and gas, I took constituent particle. Suppose these are two constituent particles and you bring them closer. So this concept of bringing them closer is known as close packing. So the solid, the close packing is very good, means you will see very less space there. Whereas in liquid and gas, no, there was some space which is present here and this space is considered as void. Whereas voids are less here. So due to this close packing, their density is high, their rigidity is high, they are highly rigid. Due to that, you cannot compress them because already they are taking maximum space available. For example, you take this box. Inside this box, if I ask you to arrange the constituent particles, then you are going to arrange it like this. So when you arrange like this, and on top of this, you do a stacking of another layer of the constituent particle, you will see a very less amount of void. This is still known as void. This is still called as void. But these voids, they are less compared to your gas and liquid part. So the answer for the last one, why solids are non-compressible, the first exclusive reason is the close packing is very good. Due to that, they are highly rigid. Due to that, the interatomic forces which is present, that is very strong. Their density is high, and that's why finally it is non-compressible. So everything is in the close packing part and interatomic force part. So this is the questions from your last session. I hope it is clear. If still you get any doubt, put your doubts on Cubase. We'll be happy to answer that. Let's move to the next. Why it is not closing? Okay, here. Now, let's start the second session. Two happy pictures, two friends, three friends. Most of you will have more than this also. But best friend is only one or two. You will not have multiple best friends. So here, two friends, here, three friends. Which concept I'm going to explain? Any idea? Bonding? No. Anything else? So today I am going to start the concept known as valency. Valency means the combining capacity of an atom. So when I take this girl, child, how many friends she is having? Consider one. So she is the friend for her. Suppose I am taking this child as my experiment So the second child is the friend. So the valency of this child is 1, means she is a friend with only one other student. So valency for this child is 1. Now let's consider this middle student or middle person. What do you think? How many friends this middle person is having? One towards the right and one towards the left. So 2. So in this case, the valency is 1, but in this case, the valency is 2. So in short, the valency is what? It is a combining capacity of an atom, that how many other atoms you can combine to become stable. Basically, whenever you combine with someone, you always do to attain stability. In chemistry, stability is done by forming bonds. Now, when this student is friend with this one, then she will share all her things, that in exam, how I study. Yesterday, my Dodama was there, my Chikappa was there. He took me out to corner house. We had some good ice cream there. So basically, that's the sharing part. So when they share things, stability comes. So today's topic is valency and formula of various compound or formulae of various compounds. So let's start that. So valency and formula of compounds. So as I said, that valency is the combining capacity of an atom. So remember the word CCOA, combining capacity of an atom. That is a standard definition of valency. Valency can also be explained like this. The valency of an atom is equal to number of the valence electron that this atom can gain or lose during chemical reaction. Now, one important term you will see here, that is valence electron. So there are two types of electrons, that is valence electron and core electron. Valence electron are the electrons which are present outside in the shell, and core electrons are the electrons which is present inside in the shell. In the coming slides, I will explain you in detail. The valence electron, either you can lose or you can gain in order to reach stability. So remember, whatever you do in nature, everything is for stability. Now, why you took admission in BASE? What is the reason? Because BASE is a very known 34-year young organization where we produce so many results in IIT, NEET, CET, and various other national and state level exams. That will help you to get entry into good colleges like IITs. There are 23 IITs are there, and NITs, triple ITs, RV College of Engineering, PS College of Engineering, like that. You will join good course, get good marks, join good company. By joining good company, I means you will get a handsome salary. And that money what you receive in your bank account, or when you do a business on your own, the startup, whatever the funds you generate, that will give you stability. Because one of the reason of stability in life is the money part. So everything in chemistry is all about stability, and you will get stability either by losing electron or gaining electron. Which type of electron? Valence electron. The chemical property of an element depends on the number of electrons present in the outermost shell of an atom. In a common term, if you have only one valence electron in the outermost shell, you can call it as the outermost room. In a common term, outermost room of your house. So the valence shell contain the valence electron, that is the last shell electron. If you have only one valence electron, the tendency of it to react will be very much higher compared to an atom which is having 5 or 6 valence electron. So one electrons, they react faster, valence electron. So basically the chemical property depends on the number of electrons in the outermost shell of an atom. I'll explain you that with time. Or let me give you a brief here only. For example, this is your nucleus. I can write it like this, visible na? This is your first shell, K shell. This is your L shell. This is your M shell. So K, L, M, N. They all are capital letter. K, L, M, N. They are the shell. Shell means basically the place where electron resides. So this is known as valence shell. And this valence shell contain valence electrons. Suppose there are two valence electrons, so I'm writing it like this. Inside shells, they have electrons. Generally, this will have 8 electrons. So 4, 6, 8. And the innermost shell will have 2 electrons. Basically, the electrons are like 2, 8, 8, 18, 32, like that. That's a magic number. With time, we will discuss that. So all the reactions, that is the electron gain and lose, is dependent on this, that is the valence electron. Electron present in the outermost shell is known as the valence electron, and these electrons determine the valency of the atom. So your valence electron is only responsible for your valency, that we will see. In case of representative elements, what it is, I will tell you. First, you listen. In case of representative elements, the valency of an atom is generally equal to the number of the valence electron, or equal to 8 minus the number of valence electron. Okay, what is the meaning of this? Let's check this out. Let me erase this. Understand this. Let me write the skeleton of your periodic table. Your periodic table skeleton is like this. Skeleton basically means the out sketch or the outline. This is a periodic table. How many blocks periodic table is made up of? Periodic table is home of electrons, where electrons are arranged in some logical way, that is increasing order of their atomic numbers. There are 4 blocks total. This is known as S block. There is a bifurcation here, demarcation. This is the P block, this is the D block, and this is the F block. So 4 blocks are there. Whether you are in India or you go to Mauritania or Uganda, the block remain the same, SPDF only. What is the full form of these blocks? Means, what do you mean by S? What do you mean by P? So S stand for sharp, P stand for principal, D stand for diffused, and F stand for fundamental. So sharp block, principal block, diffuse block, and fundamental block. So representative element is your S and P block. So these elements which is present here, the valency of these elements are nothing but they are equal to, valency is equal to number of valence electron. Number of valence electron, or valency is equal to 8 minus number of valence electron. 8 minus number of valence electron. We will discuss that with time. So S block and P block, they are known as representative element, whereas D block, it is known as transition element, which you will study with time. And the valency of D block, they are highly variable because of presence of a bigger something known as orbital, D orbital. Our focus is only on S and P, which is known as representative element. So the valency of these 2 blocks can be either calculated using the valence electron or 8 minus valence electron. 8 is a unique number that is known as octet. 8 electron means stability. If your last shell, valence shell, is having 8 electron, it means you are stable. So this is from this slide. Let's move further. Let's see this, my favorite. Now, what is this? Here, it's just like this. This is your nucleus. This is your first shell, second shell, third shell. Suppose this is your K shell, L shell, M shell. What is K, L, M? They are spectroscopic terms in chemistry. Spectroscopic means what? It is a branch of chemistry where we study the interaction of light with molecule or a compound in a simple way. So this is K shell, L shell, M shell. Generally, they are spherical. We generally write like this. But we can also represent it like this. No hard and fast rule. This is nucleus K, L, M. So these are your inner electrons, which is very stable. Inner electrons. Here it will be 8 like that. And these are your valence electrons. So M shell here is containing valence electron. So similarly, your nucleus is here, the center of your atom nucleus. This is your first shell. Suppose this is K shell, this is L shell, this is M shell. 2 inner electron known as inside electron or the core electron. 3 here, but More are there. Generally, they are 8 in number. And these are the valence electron. Valence electrons are the real actors. They perform, they sing, they dance because they only do something and entertain this part. So here these two valence electrons, they are singing. Singing means they are reacting. So inside atom, the reactivity is managed by our valence electron. Whereas the core electron or inside electron, they are just spectators. Okay, this is Virat Kohli and Rohit Sharma, and these are the audience in our Chinnaswamy Stadium. Okay, Isala Cup, Namde. Very good. So this is your inside electron, outside electron. So all the reactivity is managed by this. In our family also, we have father, we have mother. They take care of the family. They are the driving force. They are the engine of the family. They go out, they have their own business or they work somewhere. They are doctors, they are lawyers, they are engineers. And they come back in the evening and then talk to their parents, grandparents, you, their relative and all. So basically they are the driving force. So in this case, these two are the driving force for the reaction. Okay. So you don't see this part. You just focus here. Now let me explain you this also. This is your nucleus, which is generally positive. These are your core electron, 2 electron here. Here suppose there are 3, generally it is 8. And here 2 electron, these are the valence electron, outermost electron. Okay. So the valence electron is the one which react. For example, if you hit a ball, we are playing cricket and a ball comes towards me at a high speed, towards my nose, that ball will come and hit here, right? It will not go inside and hit my tongue or jaw inside or brain inside because this is outside. So this is my valence part. My nose is the valence part. Here you see the reaction because it is outermost peripheral part. So in short, valence electrons are those electrons which is responsible for any type of reaction caused due to lose or gain of electron, and they are present in the last shell known as valence shell. Good. Let's move to the next. Now let's talk about the valence electron part. I am taking sodium. Sodium is nothing but natrium. The symbol is Na. So when you take sodium, the atomic number of sodium is 11. Atomic number, you can relate it as roll number. Suppose your roll number is 37 in school, then 37 is you only. If suppose your name is Rishabh and roll number 37, suppose Rishabh Kumar. Then Rishabh Kumar is 37 is a unique number, unique identity, just like our Aadhaar card number. So this is a unique number, atomic number 11. And they are equivalent to the number of electrons. So 3 shells are there, KLM, KLMN like that. So the first shell will always have 2 electron followed by 8 electron followed by 1 electron. Okay. This 8 is the stable configuration part. So this is known as valence shell and this is known as valence electron. The arrangement is visible here. Sodium, it comes from the word natrium, a Latin word. So this is my nucleus. Inside, I have 2 electrons. Electrons generally we represent as small e with negative charge because electrons, they are negative in nature. 2 electrons, then you have 8 electrons. You can see here, this is 1, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th. So 2 over, 8 over, and this is the last one. This is my valence electron. So this is your valence electron, and valence electron will give you the knowledge about valency. Here the valence electron is 1, so valency is 1. Okay, but always it is not like that. If valence electron is 7, can valency be 7? No, then you have to use the formula 8 minus that valence electron. Let's move to the next example for your better clarity. Sodium. Okay. Okay, this was valence electron concept. Now I am going and explaining you the sodium part. Sodium, just now I explained, basically the electronic configuration is 281. So 281, this is my last valence part. Let's discuss carbon, our favorite, because organic chemistry, when we discuss now, carbon will be our day-to-day affair then. What is the symbol of carbon, guys? Symbol of carbon, quick. That's right, capital C. Atomic number is 6. So we write the configuration is 2, 4. This is my, sorry. This is my K shell. This is my L shell. How many valence electron? 4 valence electrons are there. Now, this number 4 is midway of 8. The number 8 is a unique number. It gives you stability. Octet. If you have 8 electron in the valence shell, you are highly stable. Half of that is 4. So this number is very unique. That's why you will see in future that carbon can have a valency, two type of valency. One is on the positive side, one is on the negative side. We will discuss all that. So in this case, you see carbon is having 4 valence electrons. So 2 electrons inside, 1 and 2. These are the core electrons. And 1, 2, 3, 4. These are the 4 valence electron. I am just explaining you how to identify the valence electron. Okay, good. Let's do the next one. This is your oxygen. Oxygen, what is the symbol? Capital O, correct. Atomic number is 8. So we write 2,6. This is K shell, this is L shell, this is valence shell, and this is valence electron. So 2 electrons are inside. This is the first one and this is the second one. And then you have 6 valence electrons. So this is the first, second, third, fourth, fifth, and sixth. So total 6 valence electrons you can see for oxygen atom. Let's take one metal, aluminium, and talk with respect to that. Aluminium, what is the symbol? Capital A, small l. Atomic number is 13, 1, 3. So electronic configuration is 283. Your valence electron is 3. I'm just writing the valence 1. This is first one, second one, third one. These 3 are your valence electron. For metals, I'm giving you a cheat code. For metals, the valency can easily be calculated considering valency equals to valence electron. But for non-metals, valency can be equal to valence electron or 8 minus valence electron. Okay, the second part is the more important part. We will see that. I hope this is clear. Chale? Good. Now, for metals generally, your valency of a metal is nothing but number of valence electron or electrons in an atom. Whereas for a non-metal, 8 minus number of valence electron or electrons which is present there. This is your periodic table. This is your S block. This is your S block. This is your P block. This is your D block, and down you have F block. Sharp, principal, diffuse, and fundamental part. In S block, majority of metals are there. There are around 90 plus metals and 20 plus non-metals, which is available in nature. Yesterday we discussed that exact number, you know. Now, in this case, you have Halina Kar Rab Se Faryad. So basically, this is the group 1, and then you have Beta Mange Car Scooter Baap Roe. Okay. Then you have Bagan Alu Gajar in Thali. And here, Nana Patekar Ashwarya Rai Sab Bindas. And this is Fir Kal Bahar Aega Auto. So this is the mnemonics of understanding your periodic table. When you join us, we will teach you in depth on this. Now here in S block, majority of them are metals. So metals, just now I said that when you take metals, their valency is nothing but equals to number of valence electron. This side, P block, is just like India. India is a very diverse country. We are a very big, huge country. We are very diverse. We have different languages. We have different food. We have different religions. We have different type of clothing habit. We have different type of customs in our family and in our state. P block is like India, highly versatile. Their metal is there, non-metal is there, their metalloids are there, their noble gases are there. But here, most of them are metal except hydrogen. Here, most of them are non-metals, or majority of them are non-metals. Almost all of them are metals. Here, almost all of them are metals except hydrogen. So metals, Here you have metal, non-metal, metalloid, and noble gas. So P block, I consider it to be a just like our great country India. Now, in this case, let's find out how to calculate your valency. For example, one trend is seen in case of valency. Valency trend is like this, that it will start from 1, 2, 3, 4. 4 is the halfway, midway of octet 8. Then it will come down just like this. So 1, 2, 3, 4, 3, 2, 1. So here valency is 1, here it is 2, here it is 3. Then it is 4, 3, 2, 1. Now here you will be surprised to know this is plus 1. Why it is plus 1? Because when you take sodium, the valence electron is 1, and that valence electron 1 generally it is coming out. It is lost. And whenever you lose electron, you become positive because electron is negative. Whenever you leave negative habit, you become positive. Suppose you have a very bad habit of scrolling the reels. Half an hour every day. You make it 20 minutes next day, it means you are leaving a bad habit. Okay. So that part, since this electron is lost, it is positive plus 1. In this case, magnesium, when I take, the electronic configuration is 2, 8, 2. So magnesium, it will lose this 2 electron, that's why plus 2. Aluminium, just today only I have shown you it is 283 electronic configuration. It will lose 3 electron, that's why it is plus 3. And whereas carbon, silicon and all, they are metalloids, they act as both metal and non-metal. So they can lose also and they can gain also electron. Till now, this group used to lose electron metals, lose electron because metal. But in this cases and all, they lose and gain. That's why it is -4 and +4. Nitrogen, phosphorus, arsenic, antimony, and bismuth, they are basically the first two of them, nitrogen and phosphorus, they are non-metals. So when you take nitrogen, 2, 5 is the electronic configuration of nitrogen. Now what it do, it gain 3 electrons, it add up 3 electron. When it gain 3 electron, it become 2, 8. Now this 8 becomes stability. Now in this case, 3 electron is added. Non-metals, they accept electron. Metals, they lose electron. Non-metal take it, metal give out. So the nitrogen and phosphorus part being non-metal, they are gaining electron. That's why they are negative. Suppose you have a bad habit of scrolling the reels of Insta and the YouTube shorts 30 minutes every day. Tomorrow you make it 40 minutes, you have increased your bad habit. So you are becoming negative, more negative. But if you reduce it to 20 minutes, you are becoming positive because you are reducing your time killing activity. Similarly, oxygen is also a non-metal. Oxygen electronic configuration is 2, 6. It gained 2 electron. When you add up 2 electron, it become 2, 8. Now 2 electron gain, that's why it is -2. Here 1 electron gain, that's why it is -1. So basically it starts from +1, +2, +3, +4 and -4, -3, -2, -1. That's how your valency goes. And that's why the valency is given a new term known as oxidation state that we will discuss in the coming time. So valency of metal is nothing but equivalent to number of valence electron. And for non-metals, it is 8 minus number of valence electron generally. Let's move to the next slide. Members of this group, they display a number of valency. Number of valency means variable valency, variable oxidation state, variable valency. Why? Because they have lot of empty d orbitals, which we will discuss. Now, this is again a tabular column for your valency part. So you have atomic number here, just like your Aadhaar card number and roll number. This is the name of element. This is the symbol. This is valency and repetition that side. So when you take hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon, atomic number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, the valence electron for hydrogen is 1. So valency of hydrogen is 1. Hydrogen can also exhibit +1 and -1 both. It can lose also, it can gain also. It's a mythological element, hydrogen, because it is present in most of the universe part, hydrogen and helium together. Helium, it is atomic number is 2, so the valence electron is 2, but you see the valency is 0 because there is a concept known as doublet and octet. Whenever you have 2 electron in the valence shell, and with the example of helium, and 8 electron in the valence shell, you are stable due to the rule of octet and doublet. Lithium, the electronic configuration is 2, 1. Metal, so it is equivalent to the valence electron, valency is 1. Beryllium, 2, 2, valence electron is 2 and valency is equivalent to valence electron. Boron, 2, 3, that's why 3. Carbon, 4, and after that it reduces 2, 5, so it gained 3 electron. So 3, 2, 1, 0. Neon is a noble gas, so valency is 0. So start like this: 1, 0, 1, 2, 3, 4, 3, 2, 1, 0. This 0 because this is noble gas or inert gas, they don't react. This is 0 because they are noble gas or inert gas or rare gas, they don't react. But with time, I will teach you that they also react when specific conditions are given. This side you have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. Atomic number 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. It is metal. It has it is having one valence electron, so valency is 1. Magnesium is again a metal, 282, 2 valence electron, so valency is 2. Aluminium is 283, metal, valence electron 3, valency 3. Silicon is a midway, so 2, 8, 4, valency is +4 and -4, both acceptable. Phosphorus is 15 atomic number, 285, so 8 minus 5. 8 minus 5 is giving you 3. So this is 3. I'm not writing plus and minus here because I'm just finding out the valency, the number without charge. Sulfur is atomic number 16, so we write it as 286. So 8 minus 6 is giving you 2. Chlorine is 17, a yellowish green gas, chlorine. So 8 minus 7 is giving you 1. Argon is a noble gas 0. Potassium is 19. So potassium is 2, 8, 8, 1. Metal, so valence electron and valency. Calcium is 20. So 2, 8, 8, 2. So 2 valence electron equals to 2 valency. So the trend is very simple. How the trend goes, I'm rewriting it here for you. The trend is like this. You start from 1, 2, 3, 4. It's a midway. Reduce it again, 2, 3, 1. And whenever zeros are there, they are nothing but your noble gases or your inert gases. So remember, valency goes like this, the trend 1, 2, 3, 4, 3, 2, 1, and 0 for the noble gases part. So this is the basic introduction about your valency, keeping in mind your valence electron. Now let's go and discuss about ions. There are two types of ions. One is known as cation or anion. Cation is cat. Cat is generally a pet. Pet means they are lovable, and love is a positive feeling. That's why cation is positive. That's my logic to understand. Nothing like that. No cat and all. This is your neutral atom. Neutral atom means neither. Okay, sorry. Neither they are gaining electron nor they are losing electron. So this is your neutral atom. For example, I am taking it as hydrogen. This is my hydrogen. Now hydrogen, the atomic number is 1. So 1 valence electron. It can lose 1 electron, it can gain also. Now suppose hydrogen is losing 1 electron. The moment it loses 1 electron, it will become H plus. Hydrogen cation. Positive charge. Why 1 plus? Because 1 electron you lose. Electron is negative. If you are losing a negative thing, you become positive in a simple way. Okay, there is a furthermore explanation on that. Later we'll discuss. In this case, one electron is gained or you are adding up. So here hydrogen with one electron lose. In this case, electron will be 0 electron here, but here it is gaining one electron. So hydrogen will become H minus. This is known as hydride ion. Whenever hydrogen is H minus, it is known as hydride. Now, in this case, the number of electron is 2 electron, and according to doublet rule, it is stable. An octet means 8 electron. Okay. So a neutral atom can lose electron to become a positive ion because of loss of electron. And a neutral atom can gain electron to become an ion by the gain of electron. So whenever you lose electron, you become positive. Whenever you gain electron, you become negative. So that part you remember. You want me to give you one more example? For example, I take sodium 281. This is unstable. Why unstable? Because one electron is unstable in the valence shell. So it lose one electron. The moment it lose, it become Na plus. Now the valence electron is 8, 2,8. Now this is known as sodium cation. If suppose you lose two valence electron, for example, magnesium. When I take magnesium here, there are two valence electron because atomic number is 12. So when you lose two electrons, this magnesium will become 2 positive charge. If you lose 3 electron, 3 positive charge. 4 electron if you lose 4 positive charge. Similarly, if I talk about chlorine, your valence electron is 7. You are gaining 1 electron. So when you gain electron, which is negative, you will gain a negative charge. So it becomes Cl minus. Now it will have 8 valence electron, and this 8 valence electron is known as octet. And whenever you are octet, you are highly stable. Okay. When you have 2 valence electron, you are still stable, but that is only applicable in case of helium. H minus, still it is reactive because of negative charge. Generally, neutral things, they are considered to be stable. This is considered to be stable. This is charged. Because of this charge, it becomes reactive, but because of this 8, it is stable. All that we will discuss later. You just remember that here stability is due to octet 8 electron. Here stability is due to octet 8 valence electron. Only that much. So I hope this slide is also clear. So a neutral atom giving you cation and an ion. Now ions, they are even represented by one new name. It is known as radicals. When you join us in our colleges, in the salt analysis, which will be there in your chemistry laboratory, you will be doing salt analysis. There you will encounter this term radical. So what are radicals or ions? Basically, they are almost same with a minor difference. So they are atom or group of atoms that carry a electric charge, or simple you remember it as a charge. And it is due to the loss of electron or gain of electron. Whenever electron is lost, you become positive ion. Whenever electron is gained, you become negative ion with positive and negative charges respectively. So if you are a positively charged, you are called as cation. And whenever you are a cation, you are considered to be a basic radical. So remember, basic radical, they are positive. So remember BP, blood pressure, basic, positive. So whenever you encounter the word basic radical, it is always positive in nature. Negatively charged ions, they are anions and they are acidic in nature. So if you remember BP, no need to remember the other part. So the cheat code is BP. B stand for basic and P stand for positive charge. Now, there are different type of ions or different type of radicals. For example, when I take Na plus, when I take H plus, When I take H minus, I take Cl minus, I take Br minus, I take F minus. They all are cation and anions respectively. They are known as simple ion or simple radical. Why simple? Because they are made up of similar single type of atom. It is made up of sodium atom, made up of hydrogen atom, made up of hydrogen atom, chlorine atom, bromine atom, like that. But when I take a composite radical means, okay, here I think while displaying this, the numbers are up and down. I'll write it, don't worry. Composite radicals are those which is made up of more than one type of atom. For example, I take your sulfate ion SO4 2 minus. 2 minus is superscript on the top, right hand side top. Why it is called as composite? Because it is made up of sulfur atom and oxygen atom. So combination of different type of atoms. Another example is your H3O plus hydronium ion. It is made up of 3 hydrogen and 1 oxygen. So this is example of composite radical. Another example if I take is ammonium. This is ammonium radical or ammonium ion. It is made up of nitrogen and hydrogen part. Similarly, I can write it for MnO4 minus, made up of manganese and 4 oxygen. So simple radicals are those which is made up of single type of atom, whereas composite radicals are those which is made up of different type of atoms in it. So that's the basic difference between simple and your composite radical. I hope that part is clear. Can you tell me O2 minus is simple or composite? Simple or composite? Simple, because it is made up of one single oxygen atom. Good. Now, acid and basic radicals, this is the chart. If you get confused, please remember the cheat code BP. Basic radicals are positive in nature. So these are your basic radicals. So H plus, Na plus, K plus, silver, Ag plus, Cu plus, gold plus, ammonium, mercury, Cu2 plus, Ag2 plus. Sir, why it is writing like this? Why it is writing Cu2 time plus? Can we write it as Cu2 plus? You can. That is just a way of representation. It tell that 2 electron is lost. That's also tell that 2 electron is lost. So no hard and fast rule there. So they all are positive, and this is monovalent. According to valency, the valency is 1. Here also valency 1, here also valency 1, valency 1, valency 1, valency 1, valency 1, valency 1, copper valency 2, and mercury valency 2. So that's why monovalent and bivalent is written. Your acidic radicals, basically they are anions, they are negative charged. Now, I call it as sodium. See, whenever you use the word, okay, leave it, you will get, let's focus here. Whenever there is a negative charge, you will use the word ide, chloride, fluoride, bromide, iodide, and you will also ide the word ate, nitrate, ite also, nitrite, oxide, ate, ide. So whenever you encounter an anion, the common ending term is ide or ate. Generally it is ide, chloride, bromide and all. Cl minus, Fl minus, Br minus, I minus, NO3 minus, NO2 minus, nitrate and nitrite. The formula is different. NO3, NO2, hydroxide, bicarbonate, bisulfate and cyanide part. So here it is one negative charge. So valency is 1, 1, 1, 1, 1. Again 1. Here it is one charge. So valency 1, one charge. So valency 1, one charge. So valency 1. So all are monovalent because they have single negative charge. So single negative charge means valency is also 1. If they have double negative charge, the valency become 2. For example, I take oxide, O2 minus. What is the valency here? 2. For example, I take nitrite. What is the valency here? 3. So accordingly, it changes. Clear na? Good. Now, there are many elements in periodic table in your S block, P block, D block, F block. They exhibit variable oxidation state. Variable oxidation state. So this variable oxidation state is generally exhibited by D block and F block elements. Now, why they have variable oxidation state? They have variable oxidation state due to empty d orbitals. This is one of the reason. Other reason is the energy differences which is present there. So remember that there are many orbitals. That's why they have variable oxidation state. If I give you one example, can you predict what is the valency of this? +2, +3, +4, +5, +6, +7 what? It contain everything, +3, +4, +5, +6, +7, everything. So the highest valency what you see here is +7. Good na? Manganese. Do you think this is the highest in the entire periodic table? NCERT tell yes, but there are other elements which is having slight more valency like osmium, hafnium, iridium. They are +8. Okay. +8 means they can lose 8 electron. Positive, no, so lose electron. +7 means they can lose 7 electrons. That's how it goes. So this is the variable oxidation state. It starts from +3, +4, +5, +6, +7 like that. Now, you will also encounter that there are few elements, they have different valencies, but their names are also different. For example, when I take mercury, the symbol is Hg hydrogyrum. Valency possible is 1 and 2. Mercury is a metal, so this is +1, and this is mercury is a metal, so +2. So two type of valencies are there for mercury, +1 and +2, but the names are different. Whenever you have +1 here, the name end with us. Mercurus, Mercurus. And whenever +2, the name is mercuric. The cheat code to remember is low-us. Low-us means whenever you have lower oxidation number means this only, +1, +2. Then your name end with us. So whenever you have lower oxidation number, your name end with us. And whenever you have higher oxidation number, your name end with ic. For example, tin, the word stannous. This is +2 and this is your +4. The valency part or oxidation number part. They both are same. Valency, oxidation number. Oxidation number, charge you will put. Valency, generally you don't use the charge at your level. Now, +2 means lower. Lower means end with us. Stannous. Lower oxidation state, us. Higher oxidation state will end with ic. Stannic. So stannous, stannic. Lower oxidation state end with us. Higher oxidation state will end with ic. Let me give you one more. For example, you take Cu plus and you take Cu, let's give you double plus. Copper, cuprous. Cu plus, the name will end as cuprous or cupric, correct. It will end as cuprous. And here the name will end with ic, cupric, cuprous, cupric. So remember lowest, lower oxidation state end with us. So you have few elements like that also, where depending on the type of the oxidation state, the name end with us or ic. Now, steps or step-by-step process for writing chemical formula. Now you have to write the formula, right? For example, when I write calcium carbonate, why calcium carbonate is written like this? Why it is not written as CO3Ca? There is some logic. That logic we are going to discuss. There are various steps. So identify the elements involved. Okay, identify the elements involved. Let me give you a simple example of sodium chloride. NaCl, the table salt. One good thing I will tell you. Sodium, if you eat by chance, you will be on fire. Matlab, it is highly reactive. The reaction is exothermic. It releases heat. So you will feel lot of heat content in your body. So sodium is not good for health. When you smell chlorine, the greenish yellow toxic gas, it is not good for your health. So both individually is not good for health. But when you combine them, they are required for your health. If you don't consume salt, your various body function will be hampered, just like your muscle contraction and part. So two things when they are alone, not good for you, when God combine, it is good for you. So if someone asks you in future that tell me one thing, one of the discovery of God with respect to science, which make you fall in love with God, you can give this example. Like water also. Hydrogen burns. When hydrogen burn, it burn with pale blue flame. You cannot see it. Oxygen help in burning. But when you combine them, they will shut down the fire. That is the creation of God. So identify the elements involved. So here the elements are your sodium and your chlorine. Generally, while writing the formula, we always write metal first. We always write metal first followed by the non-metal, always. So metal first followed by non-metal. Determine the valency of each of the element. So when I take this, sodium, the valence electron is 1, 281. And chlorine is 287, 7 valence electron, 1 valence electron and 7 valence electron. So valency of sodium is +1, or write it as charge only, no problem. And chlorine is, it become chloride, they're -1. Balance the valency to ensure the compound is neutral. Now in this step, Na plus and Cl minus. Balance na, 1 plus 1 negative, 1 positive, 1 negative, neutral. So that is balance, 2 positive, 2 negative, 3 positive, 3 negative. That's the balancing part. Write the chemical symbol. So first you write the metal, then you write the non-metal. Okay, valencies are there. Now these, basically what you do a crisscross like this. So when you do a crisscross method, it gives rise to this. I'm not writing the charge. This is suppose, okay, let me do crisscross. This is -1 of chlorine and this is +1 of your sodium. But we don't write that. So we avoid that. So this is Na1 and Cl1. Generally, we don't write 1 and all. So the ultimate formula, what we land is NaCl. 1 we avoid because this Na itself means 1 sodium and 1 chlorine is there. So use subscript to indicate the number of the atom, since 1 is already mentioned as 1 sodium here. So no need to write the number that we will write with time. For example, when I explain you MgCl2 now, then I will give you this. This is the subscript it is talking about 2. Write parenthesis. Parenthesis means bracket for polyatomic ion if it is needed. That also I will discuss after some time. So identify the elements involved. Generally metal is written first followed by the non-metal. Determine the valency of each element. How to determine? Metals, the valency is equivalent to valence electron. Non-metal, it is 8 minus valence electron. Balance the valency. If suppose the valency is +2, that side you make it as -2 by multiplying it with that number 2. Write the chemical symbol. So you write it, the symbol form. Use the subscript to indicate the number of atom. I am talking about this. And the parenthesis part I will explain you when I have a specific example there. So these are the various steps involved to write the formula. Let's discuss that. Few examples. For example, water. So water is made up of two elements. One is hydrogen and one is oxygen. Valency of hydrogen is 1 and the valency of oxygen is 2. Okay. And generally, I explained, that first you write metal and then non-metal, or first we write more electropositive element, then we write more electronegative element. Metal followed by non-metal, electropositive followed by electronegative. So here hydrogen is more electropositive. So what we do, it is like this. This is, my pen is having an issue. This is plus and this is minus. So I'm doing a crisscross. So this number 2 comes here and oxygen, this 1 comes there. Generally, we don't write 1 because this itself means it is 1. That's how the formula is achieved. Calcium carbonate, basically the elements involved are calcium, carbon and oxygen. But carbonate, it is having a specific type of formula. So carbonate is CO3 2 minus. Calcium is Ca2 plus. Do a crisscross. So CaCO3. This कई को करता है भाई ऐसे. So this is calcium 2 plus, carbonate is 2 minus. Now you do a crisscross. Calcium carbonate, you in betel leaf, you eat this. Now this part, I am writing it as here. And this part, I am writing it here without charge. Okay, and carbonate is CO3, so that 3 is there. Let me remove this. So CaCO3. So I can write it like this. This is the parenthesis, 2 here and 2 here. But 2 and 2, they are same. So this will nullify each other. So the formula is calcium carbonate. That's how the formula of calcium carbonate you achieve. Let's do one more, that is aluminium sulfate. So let's discuss that also. So when I take aluminium, Al, and sulfate is SO4 2 minus. Aluminium is Al3 plus. Al3 plus and sulfate is SO4 2 minus. Let's do a crisscross method. Aluminium being a metal is written first. Sulfate is written in parenthesis. Why? Because already one number is there as 4. Now this 2, I am writing it here without charge. And this 3, I am writing it here, crisscross method. So the formula will become Al2SO4 whole thrice, which you can verify here. I hope it is clear. Again, you want me to do one more time? So let's do it. Let me do magnesium chloride. So magnesium, and this is your chloride. Magnesium, the valency by now, it is plus 2 and this is 1 minus. Do a crisscross method. First you write metal, then you write non-metal. Now this 1 comes here and this 2 comes here. 1 generally we don't represent, we ignore. This is Cl2. Now why there is no parenthesis here? Because only one number is there. In the previous case of aluminium sulfate, there were 2 numbers. One was sulfate ka 4 and one was 3 also. So the formula is MgCl2. So that's how you achieve at the formula of the various type of molecules. Now let's go and find out some other examples here. Write chemical formula for a given compound. Magnesium chloride, just now I discussed, so I think that will be clear to you. So magnesium chloride, just now we discussed. What you do, you pause the lecture and write everything and later you come and check. Let me help you out with magnesium hydroxide also. So magnesium hydroxide, your magnesium is Mg2 plus, hydroxide is OH minus. Remember, the negative charge is on oxygen. Do a crisscross method. So when you do that, so magnesium and OH, this 2 comes this side. Now, since OH is together, we write it together, and magnesium, that 1 will come here, this part. But that is not required. So MgOH whole twice. So the formula for this is magnesium hydroxide, MgOH whole twice. Ammonium chloride. So we have NH4 plus Cl minus, crisscross method. Positive charge is generally written first. Now you can do a parenthesis and write 1, and you can write 1 here, but 1 doesn't make difference. So you can skip that part. So this is your magnesium chloride. Sorry, ammonium chloride. Why magnesium? Then you have aluminium chloride. So aluminium is Al3 plus Cl1 minus. Do a crisscross. So Al will take 1 and Cl will take 3. So remove 1, AlCl3. So the formula here is AlCl3. Now you do one thing, you pause it and try to do others. I'll explain you all that also, so that, oh sorry, some clarity you will have. I'll write it again, don't worry. So MgCl2, magnesium hydroxide, ammonium chloride, NH4Cl, not NH3, that is ammonia. Ammonia is NH3, ammonium is NH4. Aluminium chloride, zinc oxide is ZNO. Barium nitrate is Ba, what? Barium nitrate, what is the formula? Quick. Ba, NO3 whole twice. Potassium permanganate, what is the formula? KMNO4. Potassium chromate, K2Cr2O7. Silver nitrate, very costly. You will see in lab. Silver nitrate is AgNO3, and copper sulfate, CuSO4. 2 and 2 will get cancelled. Okay. Let me help you with barium nitrate now. Zinc oxide you want. So ZnO 2 plus 2 minus crisscross. The 2 and 2 get cancelled. So ZnO like that. So barium nitrate, Ba2 plus, nitrate is minus, crisscross. So barium nitrate will be in parenthesis. Why? Because 3 is already there and this 2 will come this side. Potassium permanganate, I'm just writing the valency, you balance it. K plus, MnO4 minus, you balance it. Later I'm writing it as K plus, Cr2O7, 2 minus. So this 2 is balancing. Ag plus and NO3 minus. Ag plus NO3 minus, that will give you. And copper sulfate is what? Cu2 plus and SO4 2 minus. Crisscross you do, you will get the answer. So if you are able to solve all this, it means the concept to write the formulas, they are crystal clear to you. I hope this is clear. Any doubt in this? No doubt, na? Clear? Okay. Let's move to the next. So the question of the day for the session 2. You have to find out the answer for these all. So total 5 questions are there. And when we start the next session, that is the third session, we will be, what happened? When we start the third session, we will be talking about, we will discuss this questions first, then we will take the third session. So let me give you a nutshell what we discussed today in the second session of the bridge course. We started with the question of the day of the session number 1. Then we went and discussed what is valency, the combining capacity of an atom. What is the role of valence electron in valency? How to find out valency for metal and a non-metal. Then we had various type of charts. We discussed that. We discussed that how a neutral atom become a cation and an anion by the loss and gain of electron respectively. Then we discussed that what are variable oxidation states. We discussed what is the reason behind variable oxidation state. We discussed the concept of lowest, what is lower oxidation state, and with us like stannous and stannic, cuprous and cupric, ferrous and ferric. Then we even discuss about the valency chart and tabular column. Then we discuss the various steps to write the formulas, the crisscross method to arrive at the formula. Today we also discuss about the simple radical and the complex radical. And towards the end, we discuss a couple of questions. So that's all from my side today. And that's it. So enjoy your vacation and khush raho, abad raho. Wherever you are, stay safe and God bless you all. Let's meet in the next session in the coming class. So tata, bye bye. See you.